this section, we're going to look at renewable resources. A renewable resource is one that tends to replenish itself. So the ones that we're going to be interested in include biological populations like forests, fish, and wildlife. If we manage our use of renewable resources, we can continue to use them for the foreseeable future. So we want to know how much of a resource we can harvest and still allow the resource to replenish itself so we can continue to use it in the future. First, let's talk about how we measure these populations, and we're going to do that with something called biomass. So we measure the size of a biological population in terms of its biomass, which is actually the physical mass of the population. So a couple of examples: if we're looking at a fish population, then we would measure that population in pounds of fish rather than the number of fish. If we're looking at a forest, we're going to measure that population of trees by estimating the number of board feet of usable timber that we could harvest from that forest, instead of by counting the number of trees. So we can represent the size of a population and how it changes over time with a reproduction curve. And you can see a graph here that shows a reproduction curve. So based on collected data or on a model, this curve predicts next year's likely population size in terms of biomass based on this year's size. So if on the horizontal axis here you find the size of the population this year, and you go up to this reproduction curve, which we're going to call f of x, then this point on the vertical axis is going to give you the predicted size of the population for next year. And it's important to know if a population is growing or shrinking. And we can tell that by looking at the line y equals x, which is added in here as a red dotted line. If the reproduction curve is above that line, then that tells us that the population is growing. And if it's below that line, then it tells us that it is shrinking. So we can tell what the increase of a population is by looking at the difference between the reproduction curve f of x and the line y equals x. So that's this little green line segment here. Tells you how much the population is going to increase over the next year. And then we've translated that over to this graph here. So this graph shows the difference between the reproduction curve f of x and the line y equals x. So you can see that when this curve is above the red dotted line, the population is growing, and when it's below the red dotted line, the population is shrinking. So one important feature is the equilibrium population size, and that's labeled here by XE. So that's the point where the reproduction curve crosses the line y equals x, and that's going to be where the population is stable, and it's going to stay the same from year to year. So once we have this model for how populations grow, we can use it to plan the best way to harvest that resource. And we want to be able to make use of a resource while sustaining its population size at a reasonable level. In the case of fishing, the yield or the harvest, H, is going to depend on the population of fish and the amount of fishing that is done. So for any level of fishing effort, the harvest is proportional to the fish population. So that means if I have a given number of boats out fishing this population, then if the population is low, the harvest is also going to be low or small. If the population is high, then we're going to have a higher harvest. For each level of fishing effort, there's a level of sustainable yield, which is one that could be sustained each year because the fish population would recover to the same level after each harvest. So let's take a look at that. So a sustained yield harvesting policy is a policy that if we continued it indefinitely will maintain the same yield. That means the same amount is harvested each year and the population remaining after each year's harvest is the same. So to get this stability, we're going to harvest the amount exactly equal to the natural increase each year. So if I've got a fish population X, let's say it's over here, and this is my natural increase curve, which shows the difference between my reproduction curve f of x and the line y equals x, then the sustainable yield here is going to be equal to the natural increase. So it's going to be this distance here. So if I harvest that many fish, then my population, that kind of gets rid of the population gain. So next year I'm going to start out with the same population, and I'll be able to harvest the same amount each year. So for a timber company or a fishery, the goal would be to harvest the maximum sustainable yield. So they want to get the highest harvest possible while still having the same population for next year's harvest. So they have that stability in there. So we want to keep the population at the size where the distance between f of x and x is the largest. So the distance between my reproduction curve and the line y equals x is the largest. And that's easiest to see over here on the natural increase graph. So that's just going to be where the peak of this graph is here, and that point is labeled xm. You can also kind of see it over here on the reproduction curve graph. So it's the distance between the reproduction curve and the line y equals x, and it's where this line is the longest. Let's finish up with an example of the decline of a fishery. So a fishery currently has maximum sustainable yield harvesting and is doing well. More fishers and boats are attracted to the area, which increases the harvest. So what happens to the yield? So here I've got my reproduction curve graph and my natural increase or population gain graph. Since more than the natural population gain is going to be harvested if more boats come into the area, so my harvest is going to be higher than my curve here, which means that next year's population will be smaller. Say it'll be somewhere over here. So next year there will be less fish available to be harvested. And if the overfishing continues and the more fishermen continue to fish that area, then the fish population is going to continue to decrease. So things you should know for this section: you should be able to understand the meaning of a reproduction curve and understand why a sustainable yield policy is needed for a harvestable resource. You should be able to estimate the maximum sustainable yield for a harvestable resource from its reproduction curve, and that's just the largest distance between the reproduction curve and the line y equals x. And you should be able to interpret the meaning of the line y equals x in relation to the reproduction curve.